Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about some advanced recovery techniques which will include the logical records onto the logical undo records and how we can recover from a failure with these log transactions of undoing an operation and including this early release of log. Till now, we have seen in an index structure the concurrency maintains means being by the crabbing protocol or in this B plus tree link protocol. Now, while we are having this type of protocol and we can recover from this failure on these protocols, that the concurrency leads to an consistent state, but in some cases we have also seen that the coalescence during the deleting purpose has led to an inconsistent state, and sometimes also it can happen that the shorter transactions has gone for a starvation for this index structure concurrency maintenance. Now what happens if we are calling this one a logical operation, that when we want to perform an insertion or a lookup, we need to lock the particular key, insert it, and as soon as possible we will release the lock. Now this early release of lock just increase the level of concurrency in an index structure. That means whenever we are performing these advanced options like this early release of lock, then we are allowing other transaction to perform the insertion or deletion at the very same time, or at least the near time it is being inserting another transaction's value. So now it is always good for us to recover from this technique that we are using this coalescing or this early release of locks. Now we can see that once the lock is released, then this lower level lock on which the early release are performing is known as a logical operation, because we are not actually having the locks on the key, but we are pretending to have locks on the key for that purpose of inserting a value into it. Now when we are doing such things that releasing the locks on the lower levels, then we are actually completing the operation on itself by doing so. Now if we want to undo the operation, then we cannot undo it because we have released the lower level locks. Now if the undo is being done, it will be a logical undo operation. So the logical undo operations are done at the lower level when the early release of locks are there. Now we will elaboratively talk about this logical undo operation. Say suppose I have a log record with Now with this log record, we can specify that a transaction with this OI, that is being an operation constant with the operation that it is beginning. So the log record that we are maintaining here are specifying that there is an operation constant with the operation that we will perform now. And if the operation is an insertion or a deletion, then we can acquire the lock at the key level, not at the root level. So now releasing the lock will give us to perform logical undo if we want to abort or roll back that transaction, because physically after releasing the lock we cannot just undo that operation. Now at the operation end, if we add this u to our log record, that means it is the undo constant. That means we are specifying that for these transactions, we may have an undo operation that is associated with this OI. Now all this type of undoing that we are performing is a logical undo, and any record that the physical storage is maintaining is the physical records or the physical operations. So this logging information that we are having is the logical logging, and when we are actually storing the search key values in the index structure, that is known as physical logging, and the record is known as a physical data record. Now, how can we proceed with this logical undo to recover from a state? Now, to perform an undo or redo on a particular transaction, we need to read that transaction as operation consistent. When we are having an operation consistent transaction, that means whenever we are redoing or undoing that particular operation on which the log record is having this u constant, will make the operation as a consistent result. That means, say suppose that a key when we want to insert a value. Now on that note, another transaction will have as soon as it releases the log by transaction ti. Now what happens, it will become an operation consistent if this will not hamper the insertion of that particular transaction ti. Now the operation becomes idempotent if at a row, if we perform the operation again and again, it will not change the result. That means, say suppose that a lookup we are performing, and after insertion and deletion of several items, the same lookup path for the search key, if the operation remains constant, then we can say that the operation is idempotent. Now, if I want to perform the transactions rollbacks using this logical undo, then we need to follow these steps for the transaction ti, which needs to be scanned backwards for performing the rollback. So after that, we have shorted down all the physical description on this record. That means the index structure is being made on this physical index and the search key is being pointed by the index. Next, we are performing an operation on it. And now we want to undo that operation. So we have made this log records operation end u. Now it has two parts. One is, first we need to perform the operation end with an undo operation, and then only we can abort that operation. As we know that for logical undo, there is no way to physically undo the operation. We need to abort the operation after having that undone constant. So now we will have Now, as we know that the rollback suggests for we need to scan the transaction backward, so we will scan it until and unless we find this one, that is my second option, that the operation begin. So we need to find all the records that belongs to this operation abort, operation undo, and finally we are reaching this. So now until and unless it reaches this transaction on this operation begin. Now my third point is going with the value, that suppose that we are reaching a transaction operation begin, and after that we are not having this operation end u, and after that we are finally having this operation abort. So what we will do, we will skip all the steps until and unless we are performing operation abort till we are having the next tj, which is for the operation begin. So now we will skip the steps or the transactions that we are performing the abort, that after the transaction we will not perform the transaction anymore and we will go to the next operation begin. However, if we have this operation end u, then we have moved to the backwards. That means the transaction which is issuing this abort to the begin of that particular transaction. So in this way we can perform the transaction rollback with this logical undo. Now we will look at a value. We can generate a log on a particular system where we can say that we are adding values for two transactions and then the feature will be get back to a result. Now let us look at this example. We will exemplify each step of this log as the two transactions are generating it. When we have T0 start, that means we are signifying that the transaction which is being started. Now we have not allocated any operation of this transaction, just in this log that the transaction is started, we are maintaining the record. Now we are having the T0 of value B, we will be previously has the 2000 and the new value is 2050. That means 50 has been added to the transaction of B. Now what we will do, we will transact an operation on an O1 begin. Now that our operation O1 is beginning, so anything after that, and if the T0 aborts before any update on this next transaction, then we will consider the updation change as a physical loss. Now we can see that my T0 is having C, that is 700 to 600. Say that's a mistake that we have made. Now if this O1 ends before the updation of this C, then the change will be physical. That means it is a physical undo if it happens before the operation ends. Now we are issuing an undo constant with operation end. So now my U suggests for C plus 100. Here we cannot do anything for the physical undo as the operation is ends after this updation of C. So now if we want to change the C, so that will be only a logical undo, not any physical undo that we can afford. So addition of this C plus 100 will be a logical undo here. Next we are starting another transaction. Now when this T0 has performed O1 as an operation end, that means it is releasing the lower level locks on C. See, this is for the logical undo, the early release of locks by the index structure on an B plus tree. That means whenever we have performed the updation or any insertion or deletion, then we will release the lock. So with the operation end command, it is releasing the lock on any lower level. Now we will introduce another operation on T1 which will begin. Now obviously T1 can access C and then update the value as C has been released on a lower level lock by T0. Now after the updation, it wants that operation end on this T1 for O2 within C plus 200. That means that will be also a logical undo before the updation of C is already there and we are operation ending on it. So this is a logical undo. But we have not operated on the abort of O1. Still, we need to see the protocol first, that until and unless we are finding the operation abort command, then we cannot perform the transaction rollback onto this undo. So the T0 cannot be rolled back while T1 can roll back because we are performing next the operation abort on O2. Now after that, T0 wants to abort its transaction. Now if after that T0 wants to update the value of C, that will also be a logical undo. So not only that operation end goes for a logical undo, after the operation abort, there will also be a logical undo. Now that I am updating T0 with the value B2000 that was previously made with the starting, not inside any operation. Now after this transaction, T0 abort. So now we can see that on not only the transaction, also the operations can be rolled back using this logical undo. And finally, as T0 aborted, so no changes made by this T0 will be affected in the database. Now finally, if we have T1 that commit its transaction, then only we can have the updates on T1 to be affected in the resultant databank. Now how can we recover from this technique using this logical undo? Now we will go for another set of transaction. We will perform the recovery that we have made here. See, our transaction has now started T0, and then it goes for an B, update the value with this 2050, and then it is committed. Now we will start another transaction. Now see, when the T1 is reading the value of B, it will be updated because we have performed T0 commit here. So now 2050 is updated to 2100, but now till we have not committed. Now we are beginning another operation. See, here we are creating a checkpoint T1 in this step. That means till now whatever T1 has done has been committed completion. That means it will be considered as completed, and if there is a rollback, then it will move till this checkpoint after the operation has begun. Again, I am performing a logical undo here by the 700 to 400. We are actually updating the value with 300 as is a part of this logical undo. Now we are starting another transaction T2. Since T1 has not committed, but we had made a checkpoint for this T1 where the C was not done and also not undone. Now we have started T2. Now we will update on T2. See, after this point, say there is a system crash on log. There is some problem on this operating system or the database or any disk failure, so we cannot maintain this log anymore. That means there is a system crash. So whenever there is a system crash, we can either do the physical undone or we can go for this redo. So now what we will do, see that after the update has been made, we have not ended the operation but just changed this C to 400. How this can be affected? Because this operation O5 has not ended and we can physically undone the effect of 400 to 300 just by making the change in a physical log. So this is by physical undo. Now we can see that there is a system crash on the log, so there will be two paths that we can make. One is an undo pass and one other is a redo pass. So the undo pass, it will consist all the log records that we have on this undone list. So all the log records on undone will be considered for the undo pass. So till now we have undone on a logical basis and physical basis for the B and C value for transaction T0 and T1. So that will be undone for this particular system crash. Now another is in redo pass. Now the redo pass will happen after every transaction that we have made a checkpoint. That means the T1 from this operation begin that a made checkpoint was, and the system crash will not affect anything before that checkpoint. So the redo pass will have the undo list for T1 from this checkpoint and the T2 that has begin after this crash. Now without ending the operation, we have performed this T2 abort. Now this one is doing a logical undo as part of the recovery. So this is all for the recovery technique that we will considering. So we had a system crash, we are doing the undo pass and the redo pass, and now we are updating this T2. Since T2 has not operation end on this undone, so we can logically undone the T2 automatically as T2 is aborted. Now we are performing the operation 4 to abort on transaction T1. Finally, we are undoing logically the value of 2050 to B, and then we are aborting the transaction T1. So all these one are part of this recovery because this we have performed before this system crash. So that is all for the logical undoing, and for that we are using the recovery technique using this logical undo. So this is the advanced techniques that we apply for the recovery, like this early rock release and the logical undo. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.